All right, welcome to our 6.1 notes. I'm going to kind of walk you through these exploration notes that you guys are supposed to do. and we're going to and we're going to go ahead and start with this first part. It says identify side, vertex, and diagonal in the picture. With that, remember, a side just needs to be two consecutive points written as a line. So if I look for my side here, I can state that my side, or a side, is AB, BC, CD, DE, EF, AF. Any of those would be considered sides. So I'm just going to write in there A, B. A vertex is literally any of those points on the outside of our figure. So A, B, C, D, E, or F. So you just literally need to name one of them. And I'm going to go with vertex B. So I'm just going to call it angle B. And then I got to identify the diagonal. Well, a diagonal is any line that goes through the middle of the figure, and the only one that actually does that is AC. Next, it says to define a side. When we are defining a side here, a side is known as a segment. So go ahead and write this in there. A segment that forms a polygon. A vertex is a common endpoint of two sides. And we say a diagonal is a segment that connects two non-consecutive vertices. Consecutive vertices. And those are our three definitions for the time being. Next, it says the following table displays polygons and other shapes, also known as non-polygons. Examine the table to determine what criteria need be to determine a polygon. So if you look, all of these shapes or all of these polygons have straight edges that do not intersect, where there is no holes or gaps. It asks you in the polygon part to circle the concave polygons. In order for a polygon to be concave, that polygon needs to have a part of their side or a part of their shape that looks like a cave or a mouth. So if you look at this shape I circled in the top left here, it is concave because it has points that go in towards the middle of the polygon. Same with our arrow and same with our star. Ones where everything looks like it's kind of bulging outwards to the outside is known as convex polygons. And convex polygons you can go ahead and shade. That actually is way too big. You can go ahead and color in or shade in. So I'm just going to go ahead and color these other two in. Because if you notice, it doesn't have any corners or any vertices that are going in towards the general shape of our polygon. So these shaded are are convex, the circled are concave. There is also another piece called regular polygons and basic polygons. If it is a regular polygon, all of its sides and angles are congruent. All of the sides and angles are congruent. It says circle concave polygons, shade the convex. Well, none of these have vertices pointing in towards our shape, so we can actually shade all regular polygons. So I'm just going to continue to shade, which you should too. And then when we get over to the right here, we just have our basic polygons because they don't necessarily have congruent angles or congruent sides, all the same. So once again, it says circle the concave, shade the convex. So since I'm in the shading mode right now, I'm going to shade my convex. So go ahead and identify those, shade them in, or color them in, however you want to call it. And you should notice that they are all similar in the fact that they have no corners pointing in towards the shape. When we go to circle here, you should notice that all of these have at least one corner that is pointing in towards our shape. Okay? And it said, what criteria must a shape have in order to be called a regular polygon? Well, we already talked about that, and we said that it needs to be equilateral and equiangular. So go ahead and write that in. It needs to be equilateral and equiangular. All right, and then next it says, draw a regular hexagon A, B, C, D, E, F. So let's go ahead and do that. A hexagon, if you forgot, is a six-sided shape. So go ahead and draw yourself a nice six-sided shape. Whoa, what in the world is that? So regular, 1, 2, 3, 4, 5, 6, and label it A, B, C, D, E, F. And hopefully your corners look a little bit better than mine do. And it says connect vertex A to every other vertex. How many non-overlapping triangles are formed? So if I make a line from A to every vertex it can, it's already got one to B, so I make one to C, to D, it's already to E, and it's already connected to F. I should notice that it creates 4 non-overlapping triangles. And in every triangle we know there's 180 degrees. Then it says, in how many degrees is a hexagon? In other words, what is the interior angle sum of that hexagon? Well, if you've got 4 triangles, each of them are 180 degrees, that should tell you that they are all 720 degrees. Every hexagon should be 720 total degrees on the inside. And then it says, use this strategy in problem 4 to fill in the overlapping table. So, number of sides and vertices in a triangle we know is 3. A quadrilateral has 4, pentagon has 5, hexagon 6, heptagon 7, octagon's 8, a nonagon is 9, decagon is 10, and an n-gon we would just say n. Then it says the number of triangles. Well, in a triangle there is only one triangle. In a quadrilateral you can make 2, pentagon 3, hexagon 4, and you should notice the pattern. You're adding one every time. Or your pattern is, however total many sides there are, minus 2. Then your interior angle sum, your triangle has 180 degrees. A rectangle or a quadrilateral has 360 degrees. Pentagon has 540, 720, 900, 1080. You should notice that you're adding 180 every single time here. 1260, 1440. And our rule actually for this is you have 180 degrees, so it's 180 degrees times the amount of triangles formed, or n minus 2. Okay, and that should be your completed table. Then our next question, based on your data in the table, what is the formula to determine the interior angle sum of any polygon with n side? This formula is known as the polygon interior angle sum. Polygon interior angle sum theorem. And you should notice that every single time we took 180 and multiplied it by n minus 2. Or the number of sides minus 2. Use the following steps to determine the measure of one interior angle of a regular polygon. It says, what is true of the angles in a regular polygon? Regular means that they are equiangular. Equiangular. Okay, and it says, how many angles in a regular hexagon? Well, we know there is 6. Based on your work in problem 5, the interior angle sum of a hexagon is 720 degrees. What is the measure of one angle in a regular hexagon? Explain how you found your answer. Well, you know there's a total of 720 degrees, and there are 6 angles, so you divide them, and you should get that one angle in a regular hexagon is 120 degrees. The table from problem 5 has been copied, but an additional row has been added. Use the table from 5 and your work from problem 7 to fill in the table. What assumption must be made to fill in the last row of the table? So I'm going to go ahead and let you fill in those first 3 rows, and I will go ahead and fill in that last row. One angle of a triangle is 60 degrees if it is regular. 90, 108, 120, 128.6, 135, 140, 144, and our rule for an n-gon is 180 degrees times n minus 2 divided by n. And that's the same part, and it says, what is your rule for a regular polygon with n sides? You do take 180 times n minus 2, all divided by n. And that is your rule. And on our last page here, it says, recall the exterior angle theorem in triangles. The exterior angle is formed by extending one side AC to point D. What is true about the measure of angle ACB and the measure of angle DCB? We do know that they are, you could either say supplementary angles, or you could say they are a linear. That's spelled really bad. Let me do that again for you. Linear pair. Okay, and it says, given the pentagon, extend one side, do not cross through the labels at each vertex to find each exterior angle, then find the sum. Well, knowing that your exterior angle is supplementary, we can go ahead and draw in there those lines and add them up. So if I start at A here, I'm going to extend a line, and 180 minus 105 gives me 75 degrees. If I extend my side, I get 85 degrees. Extend your side from 140, and you should get 40. With 80 is 100. And with 120, you should have 60 degrees. All right, and then the next piece says, determine the measure of one exterior angle for each regular polygon in order to fill in the table below. So we know sides and vertices. I'm going to go ahead and fill that in. 3, 4, 5, 6, 7, 8, 9, 10, n. Measure of one interior angle. We just did that, and it was 60 and 90, 108, 120, 128.6, 135, 140, 144, and when it's just an n-gon, we say it's 180 times n minus 2. Measure of one exterior angle, well, in a triangle, it is 120. You should notice that these two angles should add up to 180. So it's 120, 90, 72, 60, 51.4, 45, 40, 36. And for this last one, we say 360 divided by n. Your exterior angle sum for every single one, if you add them all up, should be 360. 360 degrees. If it's not, you didn't do it right. You can fill the rest of that in. Okay, and it says, based on your work, what is the polygon exterior angle? Sum theorem, it is, in order to find that exterior angle, you take 180 and you subtract the measure of your interior angle. What is the formula to determine the measure of one exterior angle? You just need to take 360 and divide it by n. This is all I've got to go through for your guided notes here. Use these to help you out in your homework. You should notice that your homework is up on the board under Wednesday, page 386, and then it goes through your problems. Have a good day. Come with, tomorrow with these completed for me. Thank you.